the model of contract debt risk. This model is designed to identify a contract with high probability going into debt. And we would like to use this model to reduce the bad debt impacting the revenue of the company. Here we will identify the most impactful parameters that affect this prediction and a simulation. A little bit about this model. This model is based on more than 70 parameters that affect the risk factor of future debt. Of course, parameters and the amount of the parameters is unique to each business case. Some example of parameters. Again, we have here payment method, whether it's direct debit or postpaid. A significant surge in service consumption, meaning if a customer usually uses 7,000 kilowatts in this area of region, and suddenly the consumption raised to 40,000 kilowatts, this is a significant surge and might impact the probability of this customer going into debt. Customer region, where the customer is located, and again, contract duration. Looking at a live scenario, we have here a contract that has been using the company's services for more than 3 years. The system identified that the contract is a potential debtor of 90%. In other words, if we do not take any action, the model is trained in such a way that in a month from now, it provides us an inference that there is a 90% of this customer will have debt with this company. Now, the average contract bill for the last 3 months has significantly increased compared to other contracts in the service area. And this contract is using postpaid payment method. Then we simulate and see that the introduction of fixed payment would lead to a greater loyalty and reduce the risk of becoming debtor to only 5%. I would like you to pay attention to the numbers, that initially it was 90% and only introduction of payment method will reduce it to 5%. Again, imagine if this action could be repeated on a big segment of contracts that taking an action on a chunk of big probability of going into debt will impact the revenue of the company. Another scenario, we had a contract with a probability of 51% of becoming a debtor. This is an average statistical contract of a customer who regularly pays bills, has average value consumption for a given region. With the help of forecasting system, we will determine what condition will cause this customer going into debt. And this is exactly the simulation we've been talking about. Now we are going to see what should happen to this customer going into the dangerous zone of going into debt. And here we noticed that the increase of consumption from almost 8,000 kilowatts to 40,000 kilowatts, the probability of becoming debtor is 73%. Now, what the company can do with such insight? For example, we can set some monitor to see if the customer is going above the regular consumption, and if it's indeed increasing the debt probability, we can take action before it actually happens. Okay, we take one step ahead. A little bit about the simulation itself, how we simulate and choose parameters to check how will it impact the final inference. So here we have the option to select manually what values we want to check to help us identify the most impactful one. So for example, as you can see here, of course, we choose the contract number on which we would like to run a simulation on. And we have the ability to manually pick values, to pick what would happen, for example, if the payment method would change from postpaid to direct debit, or what will happen if the consumption is not, for example, 8,000, it will be 40,000, for example. What will happen then? And so on, so on. The invoice, the tenure, tax exemption, etc. After we choose the values and the parameters we would like to check the simulation on, we receive the actual results. So we have the actual contract information above, the actual information and the current status of this contract. And on the graph below, we can see how the parameters that we chose impact the final probability or inference. And we can see that if we go to the right, we can see the parameters that increases the chances of this customer, for example, going debt or the probability of going short. And values that take the graph to the left side actually decreases the chances. And this is how we can manually choose and see how the parameters and the value we chose impact the probabilities.